Okay, for those of you familiar with stats, here's an example of what your calculator is essentially doing for you most of the time in stats. So here we're going to use Simpsons rule to approximate the probability of a standard normal random variable having a value between 0 and 1 and 0.6. And so we have to evaluate this interval. So I'm going to evaluate this integral. So I'm going to choose an interval of 0.1. And so if we draw out our table, like so, and then we just need to work out what our y values are going to be. So we'll definitely need our calculator for that. So we need to put this function into our calculator. So that's a little bit tricky, but we'll be able to work it out. So 1 divided by the square root of 2 times pi, and then that times e to the power of negative x squared divided by 2. Okay, now instead of x we want to put in our values. So our first value for this one is simply 0. So we put 0 in and that's the first value we get. So like before, we want to put this into our memory. So we want this one here, and then at the end of it we want it to go into our memory. Okay, so there's my first value, 0.398. So I'll go ahead and fill out the table. Okay, so now that I've got all my values in the table, I'm going to write out my integral. So we're integrating from 0 to 0.6, 1 over root 2 pi e to the negative x squared over 2 dx. And this is going to be approximately equal to 1 over 3 times 0.1 times our first value, 0.399, plus our last value, plus 4 times all of our odd values. So that will be 0.397 plus 0.381 plus 0.5352, plus all of our even values. So that's 0.391 and 0.368. Okay. So we want to put that into our calculator, and I've got all those values in my memory. So my calculator's memory, so that would be 0.5 times, sorry, should be 1 over 3, so that's 1 divided by 3, times 0.1 times our first value and our last value, and 4 times all of our odd values. So that will be C and now I've just realised I've written it incorrectly in my formula. Actually, no, I haven't. So it will be B plus D plus F, and then 2 lots of all of my even values. So that's C and E. Okay, so there's my value, 0.2257. So approximately equal to 0.2257. And this time to check, because I know that my calculator has a stats function in it, let's just use that to check. So we're going to stats mode into normal distribution, and we'll go our upper bound, lower bound is 0, upper bound is 0.6, and standard deviation and mean are 0 and 1. And there's our value you can see that our calculator gives us there. So a very close value to what our calculator gives. And in fact, our calculator probably works out our normal distribution this way. So that's an example of why we need to have numerical integration, because this function we cannot actually integrate. Alright, the work I'd like you to do is exercise 22.03, and yeah, make sure that you make it easy for yourself, and a table is a good strategy to do that.